Right. My name is Kaylee Johnson, and this is my Chapter 5 3-point test cross. Problem is, cherub wings, black body, and cinnabar eyes result from recessive alleles that are all located on chromosome 2. A homozygous wild-type fly was mated with a cherub black cinnabar fly, and the resulting F1 females were test crossed with the cherub black cinnabar males. The following progeny were produced by that test cross. And so our first step is to determine the order of the genes. So you have your parentals, which are all wild type and all recessive, and there are 750 wild types and 753. So you know those are the parentals because they occur the most frequently. And then the double crossovers occur the least frequently, and that would be the CH plus B plus CN, CHB, and CN plus. And so what you look for is the gene that is not paired or associated with the same ones it was the first time, or in the parentals. So in this case, that gene is CN, so you know that one is in the middle. And then, so the order of the genes is either CH, CNB, or BC and CH. They're the same thing, just in reverse order. So next you have to calculate the map distances. In order to do so, you look to see which formation or configuration the parentals are in. Oh, back too far. So you can see that the two parentals are in cis, which means they're all the same. They're all dominant alleles, and then they're all recessive alleles. So in order to find the recombination frequency, you have to calculate you have to find the ones that are in trans for those two genes. So our first one is CH to CN. So in trans would be CH and CN are in trans here. They're also in trans here, here, and here. And so you take those numbers from over here, add them up, and divide them by the total, which is 1800. And you get 0.5, and then you have to multiply that by 100, and you get 5 map units. You do the same thing for C, N, and B, and you get these total numbers for the progeny over the total number of progeny produced. You get 0.12 times 100 is 12 map units. Now to calculate the coefficient of coincidence and the interference, you take your map units, divide each of them by 100, because this is a probability, and you get 0.006, and you have to multiply that by the total, and so the probability, or your expected value, is 10.8 double crossovers. And so you take your observed double crossovers, which you know what they are because they are the lowest numbers. So you add them together, 4 plus 5 is 9, and you divide that by 10.8, and you get 0.83 for the coefficient of coincidence. And to calculate interference, it's just 1 minus the coefficient of coincidence, so you get 0.17. So in the second problem, you have to determine the gene order again. So you take the parentals, A plus, B plus, C plus, and then A, B, and C. And you take the double crossovers, A plus plus and A plus, B, and C. And the one that is not paired, they're cis and trans again. So the one that is not paired or associated with the ones it was in the parentals is A, so you know that gene is in the middle. So it's either BAC or CBA. Again, they're the same thing, just in reverse order. So next, to construct the genetic map, the parents again were in cis. So for B and A, You have to find all the ones that are in trans. So these are in trans, these, and this one. So you add those together and divide them by 1,000. You get 0.106 times 100, and you get 10.6 map units. And then for A and C, you also have to find them in trans, which is this one, this one, this one, and this one, and add all those up and divide it by 1,000, and you get 0.216. Multiply that by 100, and you get 21.6 map units. And so this is what your genetic map would look like. BAC is the order of the genes, or CAB, and 21.6 map units between A and C, 10.6 map units between B and A. And that is my chapter 3 3-point test cross.